We are bringing a new and novel approach to our strategy in removing PFAS, which is basically mixing two different types of media in the same column.
Human society borrow the water from that cycle for our daily usage. So we have a responsibility to return it in a condition that keep those cycle continuous and healthy.
Imagine if we could use machine learning to predict what wastewater flow or drinking water demand will be by next week.
What we're trying to do really is de-risk innovative solutions for our clients. The reason I went into environmental engineering is the mission of protecting public health and the water environment. 80% of our work is to help our clients in the near future. But then we're also interested in those crazy ideas that could have high impact in, let's say, 20 years. We interviewed clients, as well as our regional leaders and our subject matter experts, to identify our clients' challenges and match them up with gaps in the body of knowledge. PFAS, also known as forever chemicals, are soon to be regulated in drinking water by the US EPA.
They're really resistant and are present in basically all the products that we use in our daily life, such as non-stick Tupperwares, pens, and our clothing. And due to their chemical structure, they're really long-lasting to the environment and especially in our blood cells as well. So our PFAS pilot, different types of media getting mixed in the same column, and those basically will support us in trying to increase the PFAS removal capacity and also get a better hydraulic stability of the system while we are actually trying to improve our whole treatment processes at the same time.
Wastewater treatment plants are faced with growing water demands, sustainability goals, oftentimes constrained footprints, and then also budgetary restrictions when it comes to being able to build more infrastructure.
Nutrients like nitrogen and phosphorus are normally low in natural water, but human activities, especially agricultural and urbanization, add far more than ecosystem can handle. So this excess amount of nutrient cause algal bloom and water quality issues that affect both community and the environment. So we do have like traditional nutrient removal system and it works well. However, those systems require a lot of energy and additional carbon costs.
That's where process intensification can make a difference. It allows you to do more with less. Push more water through the existing basins with the existing infrastructure.
We're trying to implement more advanced treatment systems so that you can do the same job with more efficiently and with less energy. The technology we're working on, it could theoretically save somewhere between 70 to 80% of chemical demand.
Our research will provide a clear, adaptable pathway or guidance so that utility can start from the small achievable step and gradually move into more advanced and like intensified processes over time with their own pace.
Machine learning and artificial intelligence, MLAI, is foundational to everything we do in our group. So we're thinking of how we can use the tool for design, operation, and optimization of our assets. We really want the digital and the physical to evolve together to create solutions that are more adaptable and easier to operate.
In water and wastewater context, that could mean like learning how systems behave during normal and abnormal conditions and be able to forecast or optimize operational performance or identify risks before they become operational problems. We developed an ensemble machine learning model that could forecast influent flows up to 7 days ahead. We tested our model across 30 facilities in the US, and we were able to get results that on average showed less than 10% error, so that shows very high level of accuracy.
Nobody can argue that water is essential to life. It's also susceptible to global challenges such as climate change and resource scarcity. We need to use human ingenuity to help develop strategies that support adaptability, sustainability, and resiliency. It's our duty as a design and engineering firm to do that, to participate in innovation in the water space.